Okay, so this is a homework 4 preview video for Discrete math class. So I will be going over some of the similar problems to the assigned homework problems, or give you guys some hints on the actual problems itself. So I believe I assigned number 5, which is using a truth table to verify the distributive law. So to give you a hint on this problem, what I would do is make our usual table of truth and false. So since this one has three values, P, Q, and R, we would start by creating a truth table, which would look like this. So with the P, Q, and R, and this would have our usual 4 T's to begin and 4 falses. And our Q will have 2 truths and F's repeating. And our last will have the truth and values repeating. Okay, so by setting up your truth table as this to begin with, this enables you to hit every single possible categories of having the mix of truth and falses. So what I'll do is your job will be to have this side, the truth and false value of the left-hand side, and then afterwards have the truth and false values of the right-hand side and compare those values. So how I would do is I would start by creating Q or R. So this column would have the Q and R values being looked at together, so second and third columns, and I would have the OR value. So let me just get started with this row or column. So Q or R. OR means from our previous chapter or section reading, we know that as long as one of them has a true value, then it's going to take on that value. So true and true, this is going to be true. True and false, we have at least one true, so that's going to be true. So same thing, unless you have both of the rows that are have the false value, then it has to be false. So, all right, so this is what it looks like. Now, I would have this conjoined with the AND value, so my next column would have the P and Q or R. So what I'll do here is that I'm looking at this column that we just came up with and combining that with the P column, and they will be conjoined with the AND statement. So with the AND statement is that both of the values have to have a true in order for this to take a true value. And also we have T and T, so that's also T. Also another T and T, so that's T. If one of them takes on the false value, then this is going to be false. So since we have a T here and a false here, this is going to be false, and likewise, and I'm just going to fill up the rest of the row. Okay, so this is the truth and false values for our left-hand side. Now I'm going to leave the this right-hand side for you, and what you will do is you will continue with this table, and probably your next job is going to have P and Q. So fill up this column, and then the second step would be fill up P and R. And your last column, you will use these two, and these two will be conjoined with the OR statement. So you'll have P and Q, or P and R. All right, so it's expected, since this is a verification problem, you should expect this table, this row, this column, and your last column to have exactly the same value. So I would expect, as long as everything goes correctly, this will have identical values of what we have here. Okay, and after you show that, then that's the end of the verification. All right, off to the next problem. Number 7, I believe I assigned parts A and B of number 7, so I'm going to take on C to see what this means. Right, so in your textbook, you should have read what the De Morgan's law is about, and we have to find, using De Morgan's law, we have to find a negation of this given statement. So we know that the negation of or would be and none of these to have negated, we have to put not. Okay, takes the bus or not also would go here. So the final sentence for 7, using the De Morgan's law, this would be May does not walk and does not take the bus to class. All right, so number 9, I'm going to go over D because for number 9, A through C is assigned. And for this problem, we have to show that each of these conditional statements is a tautology by using the truth table. So we're creating another truth table, and let's begin by, let's just notice that we're only using P and Q. So our truth table for this is going to be much simpler. So we're only going to have P and Q, which means that I can do true, true, false, false, and this is going to be true, false, true, false. So this is all the possible outcomes of the mix of P and Q. Then next, let me do this statement first. So that's P and Q. So this column, I would write, for the end statement, this will be true as long as for both of these values have the true value. So this is true and false, false, and false. Okay. Before I take a consideration of that inference, which is the right side of the arrow, I have to look at the parentheses. So Pemdas, something that you've heard of in high school, is still puts in effect. So I'm going to go ahead and do this one first. So I'm going to do P, if P, then Q. And this from your reading and also from the exam, you should now know that if true, then true, the first one is definitely true. If true, then false, that's false, and true and true. Okay. And now I would do our final step, which is conjoining these two columns with the inference. So I can now do P and Q. If that, then the second value that we have completed. So now we're looking at these two columns, and we're conjoining them with the inference question. So if true, then true, so that's true. If false, then it's expected to be false, so that entire sentence would have a true value. If false, then true, so this is also going to be true and true. So in the end, we have everything, all the cases, satisfying or giving us a true value, which means we have shown that this is a tautology, and that's how we prove that this statement was tautology. So for A through C, which is for your homework, you should expect that your end result will be all true values. Okay. So let's go with 14. So 14 is very similar to 15, which is your assigned homework problem. So this is another true proving if this is true or not. So let's just notice it seems like they're only using P, Q, and Q. Okay, so this is another one of those simpler tables because that only takes two values. And we know it's going to be T. It's false, true, false, true, false. Okay. Look closely at the parentheses. At first, I would prove this one, or I would have it on the value of if P, then Q first. All right, so it seems like we're going from P to left to right. So this is going to be true, false, true, and true. All right, the next I'm going to have is not P. So this is just a negation of the P, which is the first column. So I'm just going to flip all the values. So true becomes the false, and false values become the true. All right, so the next one is, if not P and P, if P then Q. So this, I'm doing the whole thing, which is the left-hand side, the if side, and all you're doing is just the second and third column is conjoined by AND statement. So to satisfy the AND, to have the true value, both of the values have to be true. So T and F, that's going to give us false, and also false, and the last two values, true and true, will result in true. Okay. And lastly, I need not Q, so that's just negating the Q values from the second column, so I'm going to have false, and true. And my very last step would be connecting these, the last two columns with an inference. So I'm going to this direction, so here is, you should copy this statement right here, and let's see. So if false, then false. That's a true statement. If false, then true. Since we are resulting with a true value, this is true. If true, then false. This is false. Okay. And if true, then true. This is also true. So in the end, our answer to this is not a tautology because we have a false value here. It'll only be a tautology when all of our values have true statements. Okay, so 18, I chose 18 because 18 is similar to numbers 17, 25, 31. So let's go over how this would look. All right, show that this statement, if P then Q, and not Q then R, are logically equivalent. I'm sorry, I said R, but if not Q, then not P. So again, we're looking at P and Q, only two values, so I'm going to go ahead and make a quick truth table. Okay. All right, and I'm going to start with if P then Q. And again, that would be false, true, and true. And I'm going to go ahead and I'm going to have to create not Q column. So not Q is just a negation of their second column, which is going to be false, false, and true. And not P also is a negation of the first column, which is going to be false, true, true. All right, so our very last column is going to be this, which is not P, if not Q, then not P. So I'm looking at these two columns and we're going to the right. So let's see, if false, then false, that's a true statement. If true, then false, this is a false statement. That's true. And lastly, this is true. So now what this is doing, we have to show that this and the second given are logically equivalent. So if P and Q is right here, it's the third column, and our second is our last column. And we have to check if the true and false values are the same, and in this case it's equivalent. It's TFTT, same thing with TFTT. So this is how you show that those two statements are logically saying the same thing.